Gigantic underwater rivers, far beneath the ocean's surface, where sunlight fades and pressure rises, something extraordinary moves in silence. Real rivers, flowing not through air or over land, but deep beneath the sea. It sounds impossible, yet it's true. These underwater rivers carve channels into the seafloor, wind through canyons, and transport massive volumes of water, sediment, and life across vast distances. They're invisible to the naked eye, but as real as any river on land, and one of the most remarkable examples lies beneath the Black Sea. This particular underwater river was discovered by scientists exploring the Bosphorus Strait, a narrow, natural passage connecting the Black Sea to the Mediterranean. What they found was astonishing. A powerful current, moving with the structure and behaviour of a true river. It had banks, it had rapids, it even had waterfalls. Flowing through a submerged canyon, it carried salty, dense water from the Mediterranean down into the deeper layers of the Black Sea. And just like a river on land, it shaped the terrain as it moved. But what makes this possible? How can a river exist within a body of water? It comes down to density. When heavier, saltier water meets lighter, fresher water, it sinks. This denser water begins to move downward along the seafloor, guided by gravity and shaped by the contours of the ocean bed. As it flows, it forms a distinct channel, a kind of underwater highway. Unlike surface currents, these deep-sea rivers are narrow, fast, and remarkably powerful. In the Black Sea, this submerged river is estimated to carry over 22,000 cubic meters of water per second. That's more than the Amazon River. These rivers don't just exist in one place. They'd been detected around the world, especially where continental shelves drop into deep basins. Near Australia, underwater rivers have formed off the coast of Perth. Off the coast of California, ancient submerged channels remain as evidence of long-gone rivers. In the Gulf of Mexico, one of the largest underwater canyons channels heavy flows of sediment into the abyss. These systems shape the ocean floor, transport nutrients and oxygen to deep ecosystems, and even influence marine biodiversity. But there's something eerie about them. Because they're so hidden, so silent, we rarely consider that such immense forces are moving right beneath the calm surface of the sea. This process shapes underwater landscapes into towering ridges, deep valleys, and expansive plains. In some areas, what lies beneath the sea is more dynamic than anything found on land. In some cases, these rivers become dangerous. When fast-moving flows of water and sediment suddenly collapse, They create what's called a turbidity current. These underwater avalanches can break deep-sea cables, damage infrastructure, and even reshape coastlines. In 1929, a massive underwater landslide triggered a turbidity current off the coast of Newfoundland. It snapped multiple transatlantic communication cables, some over 12,000 feet below the surface. It took months to understand what had happened. Despite their power and importance, underwater rivers are barely known to the public. They aren't shown on maps. You can't stand beside one or hear its flow. But their impact is massive. They're responsible for much of the deep-sea oxygen exchange. They influence fish migrations. They guide nutrients that feed entire ecosystems on the ocean floor. And yet, we know more about the surface of the moon than the deep channels of Earth's own oceans. The idea that rivers flow beneath the sea feels like a contradiction. But in nature, contradiction often hides truth. These underwater rivers are reminders of how much of our planet remains unexplored, how much of its beauty is quiet and hidden. While we stare at the surface, something ancient is moving below. Not with chaos, but with direction. Not with noise, but with power. A river unseen, carrying the deep stories of Earth through silence. Bioluminescent hunting. In the darkest parts of the ocean, sunlight doesn't exist. Dive deep enough, and the world becomes pitch black. Yet life thrives there, and in the silence of the deep, something strange happens. The creatures begin to glow. Not because of external light, but because they create their own. It's called bioluminescence, the ability of an organism to produce light from its body. And down here, that glow is not just beautiful, it's a weapon. In these shadowed depths, some fish have evolved to turn light into a hunting tool. They attract, deceive, confuse, and capture prey using glowing body parts. One of the most famous examples is the anglerfish. It has a long, thin filament that extends from its head like a fishing rod. At the tip of that rod is a glowing bulb. It sways in the water like a small creature. And in this lightless world, any nearby fish that spots the glow thinks it's food. But the moment it gets close enough, it disappears, swallowed by jaws, faster than a blink. That glow comes from a chemical reaction inside the anglerfish's lure. In some species, it's made with the help of symbiotic bacteria that live in the bulb. The fish provides them a home, and in return, they provide light. This light doesn't just lure prey, it saves energy. Instead of chasing food in the dark, the anglerfish waits, motionless, until something swims right into its trap. But the anglerfish isn't alone. The deep sea is full of hunters that have turned light into strategy. The dragonfish is another predator. Along its sides, it has rows of glowing dots that flash in patterns. These pulses can be used to communicate or to blend in with the faint light above. But the real trick lies in its jaw. It has a barbel, a thin tendril hanging from its chin that glows. When the dragonfish sits still, the glow moves gently in the water. Smaller fish, attracted to the soft shimmer, swim toward it. And that's when the dragonfish strikes. Some creatures have adapted even further. The cookie-cutter shark has glowing patches along its body, making it almost invisible from below. But right near its mouth, it leaves a dark spot, a false silhouette. Larger fish, mistaking it for something small, swim closer. And then the shark tears a perfect circle of flesh from its body before disappearing into the dark. In other cases, bioluminescence is used as a distraction. Some squid and jellyfish release glowing clouds into the water, like underwater flares. While the predator stares at the light, the creature escapes in the opposite direction. It's a clever kind of camouflage in reverse, not to hide in darkness, but to blind with light. The mechanisms behind this glow are complex. At the heart of it is a chemical reaction involving luciferin, a molecule that produces light when it reacts with oxygen. This process is incredibly efficient. Almost all the energy goes into producing light, not heat. In the deep ocean, where conserving energy is everything, this matters. Some researchers believe bioluminescence is the most common form of communication on Earth. Not through sound, not through movement, but through flashes of light in the dark. Entire ecosystems down there rely on it. From tiny plankton that flash when disturbed, to large predators that use it to find their next meal. What makes bioluminescent hunting so haunting is that it flips our idea of light. We often think of light as a source of comfort, of safety. But in the deep sea, light can be deadly. It draws you in. It promises food. It looks harmless, but it often ends with a snap of jaws or a burst of venom. Here, the glow is not a gift. It's a trick. Still, it's beautiful. These glowing hunters turn the dark ocean into something otherworldly. A place where light dances through shadows, where silence is pierced by flickers, where evolution has taken a challenge, total darkness, and turned it into a stage for survival. They don't just hunt with teeth or speed. They hunt with light. Precise, patient, deceptive. We often think we've seen everything nature has to offer. But miles below the surface, entire worlds exist. And in those worlds, creatures are writing their own rules. Rules built on mystery, on biology we're only beginning to understand. Every flash in the dark is a story, a hunt, a moment where survival depends on one of the strangest powers on Earth, the ability to glow in the void. Life that thrives without sunlight, at more than 10,000 meters below the ocean's surface, the world changes. It's not just dark. It's pressure-heavy, freezing cold, and completely untouched by sunlight. Down here, the ocean isn't blue, it's black. For a long time, scientists believed life couldn't exist at such depths. The weight of the water alone would crush anything fragile. No light means no photosynthesis, no plants, no typical food chains. But as we sent machines deeper into the trenches, we discovered something strange. Life doesn't just survive down there, it thrives. The deepest parts of the ocean, like the Mariana Trench, are largely unmapped. We know more about the surface of the moon than we do about these underwater zones. But during the few missions sent into the abyss, cameras have captured things that defy what we once thought possible. Slender, ghost-like fish with translucent skin drift silently. Giant amphipods, shrimp-like creatures with armor-like shells, crawl along the seafloor. Some fish glow with faint, eerie light. Others look ancient, as if unchanged for millions of years. What's most surprising is how these creatures have adapted. At that depth, the pressure is over 1,000 times greater than at sea level. Human bones would crush. Submarines creak under the strain. Yet these animals are soft-bodied, flexible, and resilient. Their cells are different. Their proteins have evolved to work under crushing force. They don't rely on sunlight for food. Instead, they feed on marine snow, a slow drift of dead plankton, organic particles, and waste that sinks from above. Others feed off chemicals released by hydrothermal vents, or the remains of giant carcasses that collapse to the sea floor. Some discoveries are so bizarre, they don't even fit into our existing categories. In one dive, researchers spotted a transparent sea cucumber walking on long, spindly legs. Another time, they recorded a Dumbo octopus, named for its ear-like fins, calmly swimming past the camera at a depth no cephalopod had been seen before. These aren't monsters. They're proof that evolution finds a way, even in silence and pressure. The deeper we go, the stranger the rules become. Eyes are often useless. So many creatures are blind. Some have evolved to sense movement or pressure instead. Others produce their own light, not for hunting, but to communicate in the dark. Bioluminescence becomes a language when sound is swallowed and sight disappears. It's not just their biology that stuns scientists. It's how much we still don't know. Every deep-sea expedition reveals something new. A species never seen before. A behavior never recorded. A body structure never imagined. Many of these creatures aren't even formally named. They appear for a moment on screen and vanish into the black. That's why they're called unmapped. Not because we haven't seen them, but because we haven't understood them. And this raises a haunting question. If life can thrive in these extreme, lightless depths, what else might exist in places we've never looked? Some scientists now believe that if life could evolve in the crushing blackness of Earth's trenches, it might also exist in oceans beneath the icy crusts of moons like Europa or Enceladus. The creatures below 10,000 meters may not just expand our idea of Earth's life. They might change how we search for life in the universe. Still, these discoveries also carry a warning. There's something both terrifying and beautiful about this part of the world. It's a place where sunlight has never reached, where the rules of nature bend and blur, where ancient life thrives in total darkness. And yet, it exists, quiet, unseen, alive. It reminds us that Earth is still mysterious, but our maps are incomplete. That even in an age of satellites and instant data, the planet hides secrets in its deepest places. Not imaginary ones, not myths, real, breathing creatures with strange names and stranger forms. Life that glows in the dark. Life that moves with the current. Life that lives without ever knowing what light is. And perhaps that's the most powerful truth of all. That the further we descend, the more we realize how little we understand. Not just about the ocean, but about life itself. The sprites and blue jets, high above the clouds, where airplanes stop flying and satellites begin to orbit, something strange happens during thunderstorms. Not below, but above. For centuries, lightning was seen as a force that strikes down from the sky. It lights up the ground. It hits trees. It shatters silence with thunder. But in the last few decades, scientists discovered that not all lightning follows this rule. Some bolts go the other way, up. They shoot towards space. And for a long time, no one even knew they existed. Sprites and blue jets are the names given to these rare and mysterious events. They aren't myths. They're not sci-fi. They're real, but they're hard to see. They happen for just a split second, usually above powerful thunderstorms, and they vanish before the human eye can register what happened. Sprites are massive bursts of red light that spread out like jellyfish or fireworks above the cloud tops. They can stretch as high as 90 kilometers into the atmosphere. Blue jets are narrower and shoot upward from the storm clouds, glowing with an electric blue light as they rise toward the stratosphere. For decades, pilots occasionally reported seeing strange lights shooting upward during storms. But their stories were dismissed. There was no photographic proof. No instruments detected them. It wasn't until 1989 that scientists accidentally captured the first images of a sprite on camera. A team in Minnesota was filming the night sky and noticed something strange in the footage. A burst of red high above a thunderstorm, moving in the wrong direction. It wasn't lightning, at least not the kind we understood. Since then, researchers have worked to understand these upper atmosphere phenomena. Sprites usually occur when a lightning strike creates an intense electric field above the storm. That field excites molecules in the upper atmosphere, causing them to glow red. They're not bolts in the traditional sense. They're more like plasma dances triggered by distant charges. Blue jets, on the other hand, shoot from the tops of thunderclouds and can reach up to 50 kilometers into the atmosphere. They're brighter, faster, and more structured, and they glow with a rich cobalt hue. What makes sprites and jets even more fascinating is how little we still know about them. They occur in a part of the atmosphere that's difficult to study. Satellites orbit too high to catch the details. Weather balloons don't reach that altitude. Most ground-based cameras can't see them unless the conditions are just right. And yet, with modern technology, we've begun to capture more of these flashes. In 2021, the European Space Agency's ASIM observatory on the International Space Station recorded a blue jet in remarkable clarity, rising from a thundercloud over the Pacific. These events may last just milliseconds, but they raise big questions. What role do they play in Earth's electrical balance? Do they affect communication systems, weather patterns, or even the chemistry of our upper atmosphere? The answers aren't clear. Some scientists believe these upward discharges might influence the ozone layer. Others think they're part of a larger electric system that connects Earth's surface with space. A kind of silent power grid we're only beginning to detect. It's strange to think that such massive events have remained hidden for so long. But the sky hides secrets in plain sight. The atmosphere is vast, and most people never look up during storms. Not that they'd see much if they did. Sprites and jets move too quickly. You'd have to be in just the right place, at the right time, with the right equipment. Still, they happen more often than we realize. Somewhere above Earth, as storms rage below, a red tendril or a blue beam might flash upward, unnoticed. They remind us that even the most familiar forces, like lightning, have sides we've barely explored. We've studied storms for centuries. We've flown through hurricanes. We've mapped thunderclouds. Yet here is lightning that rises instead of falls, that glows red and blue, not white and yellow, that dances towards space instead of crashing toward the ground. And maybe that's what makes sprites and blue jets so compelling. They're not part of everyday weather. They're not the lightning we know. They belong to the edge, the invisible border between our world and the vast unknown above it. And in that border, things don't follow the rules. They flicker for just a moment. Then they're gone. But in that flash, we're reminded how much more the sky holds, and how much we still haven't seen. The loudest sound ever. In the summer of 1883, something happened that changed the sound of the earth itself. It wasn't war. It wasn't man-made. It came from nature, raw, violent, and beyond anything we'd ever heard before. It started with a rumble off the coast of Indonesia, in a place known as the Sunda Strait. At the center was a volcano called Krakatoa. By the end of August, it would erupt in such a massive explosion that people thousands of miles away would hear it. Not just hear it, feel it. This wasn't just a loud noise. It became the loudest sound ever recorded in human history. At around 10:02 a.m. on August 27, the final explosion ripped through the sky with a force so powerful that it shattered eardrums of sailors 40 miles away. Windows cracked hundreds of miles from the blast. In some places, people thought they were hearing cannon fire. In others, they believed it was the end of the world. The explosion was heard 3,000 miles away. In places like Australia and even islands near Africa, it moved faster than the speed of sound, crashing into the sky and pushing air like an invisible tsunami. But what caused such a violent eruption? Krakatoa had been restless for months. Small eruptions. Strange activity. But when the final blast occurred, the entire island collapsed into itself. A huge portion of Krakatoa disappeared, swallowed by the sea. It released energy equal to about 200 megatons of TNT. That's over 13,000 times more powerful than the bomb dropped on Hiroshima. And it didn't just shake the earth, it changed the sky. After the explosion, ash rose more than 20 miles into the atmosphere. It travelled across continents, creating vivid sunsets and strange red skies that lasted for years. In London, people reported blood-red sunsets. In New York, the sky turned shades of orange and purple that seemed almost unnatural. Artists captured it in paintings. Writers noted it in journals. It was as if the sky had remembered the blast and refused to forget. And then there was the human cost. Tens of thousands of people died. Not just from the eruption itself, but from the tsunamis that followed. Waves over 100 feet tall crashed into coastlines. Whole villages vanished. Bodies were found miles inland. Some were never found at all. And those who survived described a silence that followed the sound. A kind of stillness that didn't feel peaceful. It felt haunted, as if the world itself had paused. Scientists still study Krakatoa today. They know it wasn't just a volcano. It was a global event. A sound so powerful that it taught us how far noise can travel, how air can carry memory, and how nature, when it chooses, can create moments that we never forget, not because we see them, but because we hear them, or in some cases, feel them in our bones. There's something chilling about the idea that sound can be so intense it crosses oceans. That a single moment can ripple through the air and reach ears that were never meant to hear it. That a sound can leave a scar, not just on the land, but on the atmosphere, the climate, and even the way people talk about disaster. And today, Krakatoa is still there, or at least a part of it is. In the decades after the eruption, a new volcanic island began to rise from the sea. They called it Anak Krakatoa, the child of Krakatoa. It's erupted many times since, sometimes small, sometimes dangerous, as if the volcano remembers what it once did and what it's still capable of. The loudest sound in history didn't come from machines or engines. It didn't come from science fiction or technology. It came from deep within the earth, from pressure and magma and tectonic force. And it left behind more than ash and ruin. It left behind a reminder that even in the modern world, nature has a voice louder than anything we've ever built. And when it speaks like that, the whole world listens. The Skyquake Mystery. In 1972, people living along the eastern coast of the United States started reporting something strange. It wasn't a storm. There were no clouds, no rain, and no military exercises, just clear skies. And yet, out of nowhere, came a sound, a low rumble. Then a sudden, explosive boom. So loud it shook windows, set off car alarms. Some even thought it was an earthquake. But when seismologists checked their instruments, they found nothing. No tremors. No shockwaves underground. The earth hadn't moved. The sound had come from the sky. These mysterious booms weren't just heard once. They happened repeatedly. Over the course of weeks, entire towns in New Jersey, New York, and even as far south as Virginia and North Carolina reported them. They called it the skyquake phenomenon. Loud, ground-shaking booms that seemed to come from nowhere and vanished just as quickly. No planes, no storms, no explanations. People were confused, and soon they were scared. The booms would come with no warning. Some happened during the day, others at night. The sky would be completely calm. No clouds, no lightning, no thunder. Just blue sky. And then suddenly, it was as if the air had split open. The military was contacted. Weather experts were called in. But no one could give a clear answer. There were no sonic booms reported by aircraft at those times. There were no storms in the area. And nothing was showing up on radar. People started to come up with their own theories. Some thought it was secret military testing. Others wondered if it had to do with atmospheric changes or something unknown deep in the sky. A few even believed it might be a sign of extraterrestrial activity. But the truth is, no one really knew. The sound itself was unlike regular thunder. It wasn't rolling or distant. It was sharp, sudden, direct. It rattled buildings and made pets panic. In some towns, emergency lines were flooded with calls from people asking if there'd been an explosion. Fire departments were sent out. Police investigated. But each time, they found nothing. No debris, no flashes, no impact. What made it even stranger was how local the sounds were. Some people would hear the boom and feel it shake their homes, while just a few miles away, others would hear nothing at all. It wasn't global. It wasn't even regional. It was targeted, narrow, like sound that moved in strange, isolated pockets. Some scientists suggested a few possible explanations. One was upper atmosphere turbulence, fast-moving winds at very high altitudes that might generate pressure waves under the right conditions. Another was distant thunder, bouncing off layers in the atmosphere and travelling in weird patterns. But even those ideas didn't fit all the details. The clarity of the sky, the suddenness of the sound, the lack of storm activity, and the fact that no consistent cause was ever recorded. What really turned the 1972 event into a mystery was that it stopped as suddenly as it began. After weeks of repeated booms, the sky went quiet. The reports faded. The news stories ended. There was no final explanation, no government announcement, just silence. As if whatever was causing the noise had decided to leave or go quiet. To this day, the skyquake phenomenon remains unexplained. And not just from 1972. Similar reports have happened in other parts of the world, in India, Australia, the United Kingdom, and even off the coast of Italy. Always the same pattern. Clear skies, sudden booms, no explanation. Some call them skyquakes. Others use terms like mist puffers or Seneca guns, depending on where they're heard. But all of them point to one thing: sound without source, noise without origin. A reminder that the sky, for all its openness, still hides things we don't understand. The 1972 mystery didn't leave behind wreckage or physical damage, but it left a feeling, the sense that something big was happening above us, just out of reach. That the sky isn't always silent, even when it looks calm. And that not all mysteries come from the depths of the ocean or the far reaches of space. Some come from right above our heads in broad daylight. And maybe that's what makes them feel even more unsettling, because they remind us that silence isn't always empty. Sometimes it's just waiting to be broken. Tornadoes made of flames, in the heart of a wildfire, where the air ripples with heat and smoke blots out the sun, something even more terrifying can appear. Not just flames or smoke, but a tornado made of fire, a spinning column of flame that rises high into the sky, twisting like a living thing. It looks like something from a nightmare, but it's real. And it's one of the rarest, most violent phenomena nature can create. They're called fire tornadoes. Sometimes people call them fire whirls or fire devils. But whatever the name, the sight is unforgettable. A swirling vortex of heat and flame, tearing through dry land, flinging embers into the air, and making an already deadly fire even worse. They don't happen often, but when they do, it's because the conditions have aligned in just the wrong way. First, you need intense heat, the kind that only comes from a massive wildfire. Then, strong, unstable winds. And finally, a specific kind of airflow. When hot air rises quickly from the burning ground and cool air rushes in from the sides, it can start to spin. And if it spins fast enough, it forms a vortex. When that vortex picks up flames, ash, and burning debris, it becomes a fire tornado. These fire twisters aren't like regular tornadoes that form during storms. They're smaller in size, but can be just as intense. The core can reach over 2,000 degrees Fahrenheit. Hot enough to melt steel. Some grow to over 100 feet tall. Others stretch hundreds of feet into the sky. Their winds can spiral at speeds over 100 miles per hour, lifting burning branches and sending them flying, starting new fires wherever they land. In 2018, during California's Carr Fire, one of the most destructive fire tornadoes ever recorded, tore through the town of Redding. It was classified as an EF3, the same strength as a major tornado. It ripped trees from the ground. It flipped cars. It peeled the bark off trunks and hurled metal objects through the air. At its peak, it stood more than 1,000 feet tall and spun at over 140 miles per hour. It left behind a path of destruction and stunned even seasoned firefighters. The terrifying thing is how fast they form. One moment the flames are low to the ground. The next, the fire lifts into a spiral and begins to spin. In seconds, it becomes a rotating wall of heat. It doesn't move in a straight line. It dances. It shifts direction. And in many cases, it's impossible to outrun. Scientists and firefighters try to study fire tornadoes, but they're hard to predict and even harder to control. Most footage we have comes from helicopters or emergency crews on the ground. And even then, the view is usually distant, blurry through smoke and heat. Yet even in grainy footage, the sight of a flame spiral rising out of the earth is unforgettable. Some fire tornadoes are brief. They flicker for seconds and vanish. Others can last several minutes and travel across large distances. What makes them dangerous isn't just the flames or the heat. It's the wind. The fire itself is drawn upward in the vortex, but the base spreads outward, tossing burning material across areas thought to be safe. Firefighters say it's like battling a wildfire and a tornado at the same time. What's more worrying is that as wildfires grow more intense and widespread, especially in areas like California, Australia, and parts of Canada, the chances of seeing more fire tornadoes increase. The heat waves, the dry land, the shifting winds, all the ingredients are appearing more often. That means these rare events might not stay rare. There's a strange beauty to them. Watching a spinning tower of fire against a smoke-filled sky feels unreal. It's violent, but it's also a display of nature's raw power. Fire, wind, and heat combining into a single, moving force. Something ancient and untamed. Something that reminds us we still don't fully control the world around us. When a fire tornado forms, it doesn't come with warning sirens or forecasts. It just happens, and by the time it's visible, it's often too late to stop it. That's part of what makes it so unsettling. It appears out of the chaos. It adds new danger to an already deadly situation. Fire tornadoes are a reminder that fire isn't just a threat on the ground. It can rise. It can spin. It can turn the air itself into a weapon. And when that happens, even the bravest crews have to step back. Because sometimes all you can do is watch and hope it burns out before it finds you. Wind that strips skin. There's a kind of wind that doesn't just howl, it punishes. It doesn't just chill, it scours. In the coldest, most remote parts of the planet, there's a wind so fierce, so relentless, it's been known to tear tents from the ice, snap cables, and even strip skin from exposed flesh. This isn't a storm or a hurricane. It's something called a katabatic wind, and it begins with silence. High above the Antarctic plateau, air grows cold. Not just cold, colder than anywhere else on Earth. The ground temperature can plunge below -100 degrees Fahrenheit. Cold air is heavy, denser than the air around it. And on the high Antarctic interior, that dense air begins to slide downhill, slowly at first, then faster and faster, as gravity pulls it down the ice slopes toward the coast. It builds speed, sometimes reaching over 200 miles per hour. From shifting pressure systems or heated air, katabatic winds are driven purely by gravity. Think of it like an invisible avalanche of freezing air. And because there's almost no friction on the smooth ice sheets, nothing stops it. It keeps accelerating, sweeping down valleys and ice cliffs, gaining momentum until it becomes a roaring force of destruction. In some parts of Antarctica, katabatic winds are constant. Scientists working in these regions describe entire weeks where the wind never stops. It rattles metal, peels away insulation, and freezes skin in seconds. Anything left exposed is at risk. Equipment, supplies, human flesh. That's where the phrase "wind that strips skin" comes from. It's not just metaphor. In the wrong conditions, these winds can quite literally cause frostbite in under 30 seconds. The moisture on your skin freezes instantly. The tissue hardens, and if you don't protect yourself, it dies. In 1912, during the ill-fated Terra Nova expedition, British explorer Apsley Cherry Garrard described the Katabatic winds as the worst weather on Earth. They shredded tents, buried sledges in drifting snow, and froze ink inside pens. Even the toughest men found themselves crawling on the ice, unable to stand against the pressure. Every breath hurt. Every inch of exposed skin turned white with frost. And yet the wind kept blowing. But these winds aren't always violent. Sometimes they arrive quietly at night, when the sky is clear and the stars burn bright above the ice. There's no warning. The temperature drops. Then the air begins to slide. You don't hear it right away. You feel it, like a wall of ice brushing against your face. Then the sound follows, growing from a whisper to a scream. Before long, you're in the middle of something ancient and unstoppable. Katabatic winds don't only happen in Antarctica. You'll find them in Greenland, Alaska, and even in smaller forms near mountain ranges or glaciers. But nowhere are they as strong or as deadly as on the Antarctic coast, in places like Terra Nova Bay and the Adelie Coast. Wind speeds of 150 to 200 miles per hour have been recorded regularly. That's stronger than many hurricanes. And it happens without warning or cloud cover. They shape the land. The snow in these regions is blown away so often and so thoroughly that the ice beneath becomes polished like glass. In some spots, rocks are exposed, rare in Antarctica, simply because the wind has scoured the surface for thousands of years. They also shape life. Few creatures can survive in these zones. Penguins and seals avoid them. Only machines and the occasional researcher dare to stay. Scientists study katabatic winds not just for survival, but for what they can teach us about the planet. These winds play a role in Antarctica's climate, in the formation of sea ice, and even in the patterns of ocean circulation. But they're unpredictable. They don't follow the usual rules, and that makes them dangerous. Imagine standing on the edge of the world. The sky above you is endless. The ice beneath you creaks. Then, from somewhere unseen, the air begins to move. A wind so cold it burns, so fast it knocks you down, so dry it pulls the moisture from your skin. You pull your hood tight. You brace yourself, and still it comes, That's the power of the katabatic wind. Not loud like a thunderstorm, not wild like a tornado, but quiet, precise, and cruel. It doesn't destroy in bursts. It wears you down. And as it passes, you understand something about Antarctica. It's not just cold. It's alive. And the wind is its voice. Rain of blood. Sometimes the sky bleeds. Or at least it looks like it does. Imagine walking outside to find your car streaked with crimson, puddles reflecting a dull red sheen, and rain falling like liquid rust. It's rare, but it's real. Across history and continents, people have witnessed something called blood rain, a phenomenon where rainfall appears red. And while the name sounds like a horror story, the truth behind it is just as strange. For centuries, blood rain was seen as a bad omen. In ancient texts, it was described as a sign of war, death, or divine anger. People believed it was actual blood falling from the heavens, a punishment or a warning. In 8th century France, it was reported that red rain soaked the ground and terrified villages. In 1608, in what is now Italy, blood rain was said to fall for days. Panic followed. And with no scientific explanation at the time, fear filled in the gaps. Today, we understand it differently. Blood rain isn't blood. It's regular rain coloured by something carried in from far away. Usually, desert dust or microscopic life. When strong winds whip through deserts like the Sahara, they lift fine red dust high into the atmosphere. That dust can travel thousands of miles, crossing oceans and continents. If it meets a rain cloud along the way, the particles mix with moisture and fall together. The result? Rain that looks red, rusty, or muddy. In places like Spain, Greece, or even parts of the UK, this has happened many times, leaving behind red-streaked buildings, cars, and roads. But dust isn't the only explanation. In some cases, blood rain is caused by tiny living organisms. In 2001, a strange red rain fell across parts of Kerala, India. It stained clothes, rooftops, and skin. At first, people thought it might be pollution or even a meteor event. But when scientists analysed the droplets, they found something unexpected. Cells, microscopic red spores, possibly from a type of airborne algae. These spores had pigment, but no DNA could be identified at first. That mystery sparked wild theories. Some believed it was alien life, seeded from space. Others thought it might be volcanic material or a rare species of terrestrial algae lifted into the sky. Years later, more tests suggested it was indeed a kind of algae, blown into the atmosphere and spread by wind and rain. Still, not every case has been explained so clearly. In some historical reports, there's no clear source. Only red water falling from the sky and the fear it left behind. What makes blood rain so unsettling is how it looks. Red is the colour of danger, of injury, of something unnatural. When the sky turns grey and the rain starts to fall, we expect water. But when what falls looks like blood, even the most rational mind hesitates. It's not just science at that point. It's psychology. Our brains are wired to notice colour changes, especially red. So when the world suddenly appears tinted with it, it feels like something is deeply wrong. That's why blood rain still makes headlines today. Even though we understand the causes, dust from Africa, spores from the ocean, pollution particles from industry, the effect is always strange, always unsettling, and always memorable. Some regions have even learned to predict it. Weather services in southern Europe now issue warnings when Saharan dust is expected to mix with rain. People know to expect dirty cars, red puddles, and eerie skies, but prediction doesn't remove the mystery. The first time you see red rain, it doesn't feel normal. It feels like a glitch in the world. In a way, blood rain reminds us of how connected everything is. A storm in the Sahara can paint the skies in France. A colony of microscopic algae can drift on the wind and fall with the rain thousands of miles away. It's not a curse or a sign from above. It's the planet breathing, moving, mixing. And yet, it still stirs something ancient in us. Maybe that's why stories of blood rain continue. Because even when the science is known, the feeling it creates, that something powerful is happening, remains. A red sky, a red earth, a strange silence as the rain falls. Not blood, not war, just dust, just spores. But seen through human eyes, it becomes something more, something unforgettable. The rainiest place on earth. There's a place on earth where the rain never really stops. Not for days, not for weeks. For months on end, the sky weeps. This place is Mawsynram, a small village tucked into the hills of Meghalaya in northeast India. On paper, it holds the world record for the most rainfall in a single year. Over 11,000 millimeters. That's more than 30 feet of rain. Enough to flood a 2-story building. And it doesn't just happen once. This kind of rain is normal here. Predictable. Relentless. When you first arrive in Mawsynram, it doesn't look extreme. The hills are lush, green and peaceful. Mist curls around the edges of cliffs. Water drips from leaves. The village itself is modest. Tin roofs, narrow roads, homes built to endure the weather. But everything about life here is shaped by rain. People time their chores around the forecast. Crops are planted carefully to survive long, wet seasons. Even the sounds of everyday life are muffled, absorbed by the endless patter of water. What makes this place so wet is its geography. Mawsynram sits right in the path of the Indian monsoon, a seasonal wind that carries moisture from the Bay of Bengal. As this moisture-laden air moves inland, it crashes into the Khasi Hills, where Mawsynram rests. The hills force the air upward. As it rises, the water vapor cools and condenses, and then it pours, hour after hour, day after day. The village is perfectly positioned to receive the full force of this weather system. It's not just rainy. It's engineered by nature to be soaked. During the peak monsoon months, usually June to September, Mawsynram transforms. Roads turn to rivers. Schools sometimes close. Daily routines slow. People use giant banana leaves as umbrellas. Roofs are weighted down with stone slabs to prevent the relentless rain from tearing them off. Thunder rolls across the hills like distant drums. And when the rain isn't falling, it still hangs in the air, heavy, humid, waiting. But it's not a miserable place. Far from it. For the people of Mawsynram, rain is just part of the rhythm. Children grow up playing in puddles that never dry. Elders read the sky like a book. The culture here is adapted to the weather, not in resistance to it, but in harmony with it. Homes are built high with raised foundations. Paths wind uphill to avoid water pooling. Music, traditions, even the local language carry echoes of the natural world. The landscape around Mawsynram is shaped by rain too. Waterfalls burst from cliff edges. Rivers run full and fast. The ground is covered with dense forest, vibrant and alive. It's one of the greenest places on Earth, and some of the most unique natural wonders thrive here. Like the living root bridges. These are not built, but grown. For generations, villagers have guided the roots of rubber trees across streams and gaps. Over decades, the roots weave into walkable, living structures. They don't rust. They don't wash away. They grow stronger with time, nourished by the very rain that dominates this place. But with this much rainfall, there are challenges. Landslides are a real threat. Roads get washed out. Mold and moisture damage homes. And climate change has made things less predictable. Some years bring more water than expected, others less. The balance that Mosinram has maintained with the monsoon is delicate. And even here, on the roof of the world's rainfall records, that balance is starting to shift. Still, Mosinram remains a quiet, powerful reminder that nature doesn't just shape places, it defines them. Here, rain is not a nuisance. It's not background noise. It's life. It's history. It's everything. While much of the world chases the sun, there's something hauntingly beautiful about a place that leans into the rain instead. A place where every leaf glistens, every stone is slick, every breath feels thick with water. A place where the sky never fully clears. And where no one really expects it to.